Last lesson when we were looking at simultaneous equations, we were only looking at linear equations. So there was two variables, generally an x and a y, and if you were to graph them, you would get a straight line. Today we're going to look at other types of simultaneous equations. So some of them will involve higher orders, quadratics and things like that, and some of them will involve more than two variables. So you may have an x, a y, and a z, in which case they're not straight lines, and solving them can get a little bit more complicated. So we'll go through a couple now. So if we've got an example like this, x equals y plus 3 and x squared plus y equals 27. So the second equation is a quadratic, and that means that we're going to get more than one possible solution for your x. So because the first equation is x equals y plus 3, it's going to be quite easy to substitute that in to the equation number 2. So what we're going to do is get y plus 3 all squared plus y is equal to 27. So expand it out, y squared plus 6y plus 9. We've still got the plus y equals 27. Now we have a quadratic, so we're going to collect the like terms. And now we're going to factorise to find our solution. So y squared plus 7y minus 18 is going to factorise to y plus 9, y minus 2. So what that tells us is that y is equal to 2 or negative 9. So we've got two possible solutions for y. We need to substitute both of those back in to get solutions for x. So if we sub y is equal to 2 into the first equation, we get x equals 2 plus 3. So x is equal to 5. So our first set of solutions is x equals 5, y equals 2. And then we've also got to consider the y equals minus 9. So x equals minus 9 plus 3, so it's minus 6. So this solution is x equals minus 6, y equals minus 9. Now this example doesn't involve quadratics or anything like that, but there has more than two variables. So if there are three variables, you need three equations. So the way to solve this is like we were doing before when we had two variables. It's just going to involve more steps in order to eliminate the variables. So we've got equations 1, 2, and 3. Now if I add equations 1 and 2, the c's are going to disappear because we've got a negative c in the first one and c in the second. So that'll leave me with 3a plus 2b is equal to 15. So I've eliminated c. I need another equation that's just a and b with no c. And in equation 3, I've got 2c. So what I'm going to do is take the third equation and I'm going to subtract two lots of the second equation, because then I'll have 2c minus 2c and the c's will disappear again. So a minus two lots of 2a, so I get negative 3a, and negative b minus two lots of b, so I get negative 3b, and that's going to be equal to negative 12. Now I know we don't like working with negatives, but the reason we've done this is because then I've got 3a in equation 4 here, and I've got negative 3a in equation 5. So when I do equation 4 plus equation 5, 3a minus 3a, the a's disappear. So 2a minus 3b, I get minus b is equal to 15 minus 12 is 3, so therefore b is equal to negative 3. Now I can substitute that into any of the equations above, but you want to substitute it into 4 or 5 because then you'll be having an equation with one variable, the a. If you use 1, 2, or 3, you'll still have an equation with a c in it. So I'm going to substitute that into equation number 4. So I get 3a plus 2 times negative 3 is equal to 15. So 3a is equal to 21 and a is equal to 7. So now I know what A and B are. I can take both of those values and substitute them into equations 1, 2, or 3 to get the solution. I'm going to do equation 1 because it's just A and B and C, and that just makes it easier. So we're going to substitute back into equation 1, and I get A plus B minus C is equal to 2. So 4 minus C is equal to 2, so C is equal to 2. And there are your three solutions. So A equals 7, B equals -3, and C is equal to 2. So there's nothing new there. It's what we were doing before. There's just more steps that you have to go through to isolate each of the variables. That's what you need to be able to do exercise 3.12 and 3.13. Good luck, and I'll see you in class.